Hey guys, in this lesson we would understand the applications of factored form of quadratic relations. Let's read the first question. A soccer ball is kicked from a point 23 meters to the left of the halfway line and lands at a point 17 meters to the right of the halfway line. It reaches a maximum height of 10 meters during its parabolic flight. We have to sketch a graph to show the flight of the soccer ball if the halfway line passes through the origin. Let's say we have a coordinate axis as this because we are given the left side distance and the right side distance from this y-axis. How do we know this is y-axis? Is because they are saying that 23 meters to the left of the halfway line and the other side is given to us as 17 meters to the right of the halfway line. And here they say that this halfway line passes through the origin. So we know 23 meters would be negative 23 coordinate and 17 meters would be a positive 17 coordinate from the y-axis. Now the next part of the question says that it reaches a maximum height of 10 meters during its parabolic flight. So we know the maximum height, but we don't know where is it going to reach its maximum height at. If the x-axis represents the distance and y-axis represents the height of the soccer ball, and let's say 10 meters is here, then it is very clear from the question that when the soccer ball is kicked from 23 meters to the left of halfway line, that means at 23 meters left or at negative 23, the soccer ball is on the ground. And when it lands at a point 17 meters to the right of the halfway line, it is again on the ground. So these two are going to represent the x-intercepts or zeros or roots of the parabola that the soccer ball is going to follow. We know the maximum height reached by soccer ball is 10, but we don't know where we would see or at what distance we will see this height. However, we know one more thing, that the distance is going to be right in between negative 23 and 17 value because parabolas are symmetrical graphs. So we would find out the median or average of negative 23 and 17 by adding these two values and dividing by 2, and we would get negative 6 divided by 2, which is negative 3. That means at negative 3 distance, the height of the ball is going to be 10 meters. Now we can join this point, which is the vertex of this flight, and these two are the x-intercepts. So we would join these 3 points in order to complete our graph. So this is how the parabola is going to look like. That represents the flight of the soccer ball, and that's what gives us the first part of this question. Second part of the question says determine an equation to represent the path of the soccer ball. So we want to write on the equation of this graph. As we know, we are given the two x-intercepts. So we would write on the equation in factored form. That is y is equal to a x minus r x minus s form. Negative 23, 0 is one x-intercept and 17, 0 is another x-intercept. Vertex we are given is negative 3, 10. So our r value is negative 23 and s value is positive 17. How do we substitute these r and s values in the equation is, because r is negative, we would put it inside the bracket with a positive sign, and s is positive, we would put it inside the bracket with a negative sign. Always remember, r and s values go with opposite signs inside the bracket. Reason being is the general equation has a negative sign in between x and r. So if r is negative 23, that negative and this negative sign will make it a positive. Now we know in order to complete the equation, we need to fill in the value of a, r and s. R and s we have already got, but we have to now find out the value of a. For that, we have to pick any point from the parabola to substitute that as x and y. And the point that we can use is this vertex point because we know the x and y of the vertex. So x is negative 3, y is 10. We would substitute y as 10 and x as negative 3. Negative 3 plus 23 is 20. Negative 3 minus 17 is negative 20, and this would give us a negative 400 multiplied by a equal to 10. So a would be equal to 10 divided by negative 400. That gives us a value equal to negative 0.025. Now once we get the a value, we can write on the final equation, and the final equation is y is equal to negative 0.025. In the bracket we would put in x plus 23, x minus 17. This is our final equation for this particular question. Let's take up another type of problem, and the question is, the path of a football can be modeled by the equation h equal to negative 0.0625 d minus 56, where h represents the height in meters of the football above the ground and d represents the horizontal distance in meters of the football from the player. Now here we have to note one thing, that we are given the equation in the question, so we just have to figure out what type of equation is this. You know, there is no square over anything. That means this is not the vertex form, and this is not the standard form as well, because standard and the vertex form we would always see a square on top of the bracket. However, here since there is no square, so this is definitely factored form. We also know that the general form of factored form of equation is y is equal to ax minus r x minus s. So how does this relate to this form is, let's write on the equation underneath this, and we have h equal to negative 0.0625 d. Let's put this in a bracket, and then d minus 56. Now from here we get to know that this is definitely going to be a value, and this 56 is definitely going to be s value. So where is the r value? If r is missing, that means r is 0. So we can rewrite this equation to match exactly the general form, and that is negative 0.0625 d minus 0 d minus 56. So r is given to us as 0 and s is given to us as 56, and a is given to us as negative 0.0625. This is how we know that this equation is definitely in factored form. Now we have to sketch the graph of this relation. In order to make a graph of a factored form of equation, we need the r and the s values. R is 0, s is 56, and we need the vertex point, that is hk. So let's say this is 0, this is 56. The x-intercepts or zeros are going to be 0 and 56. Now we already got the r and s values. The next thing we need to get is the hk. We know h is halfway in between r and s. So we add r and s and divide it by 2, and that would give us 28. 28 is right in between 0 and 56. Now we use this equation to sub in distance d as 28, because the x-axis would represent the distance and the y-axis would represent the height in meters, as the two variables given to us in this particular question is height and distance. Now to get the k value, we have to solve for y, as the equation is y equal to negative 0.0625 d minus 56. We would sub in this h value. Always remember, do not confuse this h with this h, because this h represents the height, whereas this h represents the axis of symmetry. So this is basically x and y of vertex. So this h, just to avoid confusion, we can write down x of vertex. So we are given x of vertex as 28, and x of vertex in this particular question is also called the distance at which we would see the maximum point. Therefore, we would sub in the x of vertex as distance, and that is 28. We get negative 0.0625. Here we get 28. This is 28 minus 56. We get a negative 28. When we put this all on the calculator, we will be able to get a positive 49. And this y value is nothing but the height on the y-axis. So we get height as 49 meters. Or this is the maximum point of the parabola. So we would be marking this vertex or the maximum point at 2849. Now we have 3 points, and after connecting these 3 points, we would get the complete path of the football in the form of a parabola. And this is how the parabola is going to look like. So for this question, we've got the equation, we've got the graph. Let's go over the next part of the question. The next part of the question says, at what horizontal distance does the football land? Now we know when the football is kicked, it's kicked at this point, it goes up, reaches a maximum height and starts falling down. When it falls down, it reaches the ground at 56 meters distance away from where it was kicked originally from. Therefore, looking at the graph, we can answer this question. The question, if wants us to find out the horizontal distance where the ball lands, we can see that this ball lands at 56 meters from the origin. So the answer for this question is 56 meters. Next part of the question says, at what horizontal distance does the football reach its maximum height, and what is its maximum height? We already know that it reaches its maximum height at 28 meters and its maximum height is 49 meters. So all we have to do is just put this as an answer in part C. So at what horizontal distance does the football reach its maximum height? This horizontal distance is 28 meters. And what is its maximum height? The answer to that is 49 meters. And that's how we answer the questions when we're given the equation in factored form of quadratic relation.